All right. It's a pleasure. It's a pleasure to be back in New Jersey. Gotta say. Is that it? Is that the introduction there? Okay. Okay. Let's see if we can't put them all to sleep. Listen, what I thought I'd do, because Jim says you've got to be out of there by 11:30. So I thought what I'd do is start off by, just prattling at you for 30 or 40 minutes, maybe no more than that, and then use the rest of the time to have you grill me like a cheese sandwich and ask all those questions that you really want to know the answers to. Because whatever I say, you either know it or you don't know it. But it's not as interesting as asking whether aliens have really landed in Rahway. Okay. Let me say that the SETI Institute, which by the way is where I am, it's a Saturday. It's a Saturday afternoon here, 3 hours earlier than it is on the East Coast. But there are a couple of people in the building here, but not too many because they turn off the air conditioning on the weekends, so it's not all that attractive. But the SETI Institute has, I don't know, more than 100 people work here. But the number of people that do what I do, which is SETI, trying to find out if there's anybody out there that's as clever as the average New Jerseyite, that's a very small number of people. That's fewer than are sitting in the front row of the audience where you are. That's how many people are doing that. Worldwide, the total number of people who are doing SETI is maybe, I don't know, 10, 12, 14, something like that. A very small number. And I might say, although I'm not sure it interests you, but I might say that they're all Americans. There's nobody doing SETI these days in other countries. That didn't used to be the case when I first joined the SETI Institute quite some time ago now. The Soviet Union, which still existed, was very active in SETI. They were doing it. And there were some experiments elsewhere, too. 5 years ago, there was an experiment in Italy, but now it's all Americans. And I ask you, why is it that it's only Americans who are looking for ET, right? Is it because they don't have the equipment or they don't have the money or they don't have the interest? The Europeans, I've lived in Europe, the Europeans, they have all of that stuff. But there's something about the culture that's different in the United States. I just offer this to you for your delectation and consideration why it is that these days, when it comes to looking for life in space, many countries are interested in that. They're sending probes to Mars. They want to look at Europa or Ganymede, Callisto, Enceladus, Titan, all these places that might have life. But essentially no one other than a few small groups in the United States are looking for intelligent life. And could that be because, intelligence is kind of rare? Well, just walk around your neighborhood and decide for yourself whether intelligence is kind of. But, and there is a real point there. I only mention it to you because a lot of evolutionary biologists get their knickers in a twist about this. If you say, I'm going to give you 1,000,000 worlds with life, there are 1,000,000 worlds where you get microbes and just let them sit there for billions of years. A really difficult question to answer is how many of those planets will ever cook up something as smart as we are? And some people say, oh, come on, of course it's going to happen. It happened here. I mean, there's nothing miraculous about Earth. That tends to be my opinion, by the way, but it's only opinion because there are plenty of evolutionary biologists who would say, hey, did you forget that 66 million years ago, a big rock slammed into what's now the Yucatan of Mexico, wiped out the dinos, yeah, but it wiped out 2/3 of everything else. Okay, and if that rock had arrived, 10 hours earlier, it would have missed the Earth entirely, and you wouldn't be sitting through this. There would be dinosaurs in New Jersey. Okay, so, maybe you could say, oh, well, yeah, all right, maybe, but the dinosaurs would have gotten smart. Just give them, some time. They were on their way. It's not clear they were on their way. In fact, when I asked an evolutionary biologist down there at the American Museum of Natural History over in Manhattan, when I asked him about this years ago, he said, look, Seth, the dinos had 150 million years to get smart and didn't. So what would another 66 million years have done for them? So it's a really interesting question. Just because you have a lot of life, maybe you don't have much intelligent life. And I would say that maybe it's that argument, who knows, that has swayed so few countries to actually get into the SETI game. Let me tell you a bit about what we're doing in SETI these days. How many of you think that the aliens are out there, by the way? Just raise your hand. Anybody? Yeah, well, why? And how many of you think, no, probably not? There's one guy back there. I want to talk to you later. Okay. Yeah, but I mean, tell me why not? There's the guy back on the right-hand side of the hall facing the front. He's about 4 rows back with a beard. He just turned. He turned the other way. Anybody say no? Yeah, they're afraid. Okay, it's too bad. So you all think that they're out there. Well, you've watched a lot of television and movies. But if you all think they're out there, there's really no point in listening to me because you're already convinced. We might as well go out to, dinner somewhere at a rib place. The thing is that what's interesting now is that, uh, I mean, what's new in the SETI game? That's really what I'm going to get after. We think they're out there. Obviously, we wouldn't do this job if we didn't. I'm in the Silicon Valley here. I'm in Mountain View, California. That's about an hour south of San Francisco. I'm surrounded by high-tech firms. There's one about a mile from where I'm sitting called Google, but it's not the only high-tech firm here. There are many others. And, anybody at this place could double their salary by walking across the street and taking a job in high tech. But they don't do that. It's not just because they're stupid about this. It's because this is a very interesting question we're trying to answer. And it's hard to do it because it's run on the basis of, donations. It's not the SETI work is all run on the basis of donations. But there are very few people here doing SETI because of that limitation in money. Almost all the other people, 95% of all our scientists are not looking for ET. They're just looking for life in space, right, on Mars or some of the moons of Jupiter and Saturn. And for that, they can get grant money from NASA. So just so you know what the SETI Institute does, it does SETI. That was its first project, hence the name. But it also does a lot of what's called these days astrobiology. Okay, I won't talk about astrobiology unless you insist that I do. But let me talk a little bit about SETI and what we're doing today. We have a bunch of telescopes. I heard from Jim that you guys have a bunch of telescopes. Ours are radio telescopes, so they look like backyard satellite dishes. They're bigger than your average backyard satellite dish, but not that much bigger. They're 6 meters. They're about 20 feet across. Okay, and we have 42 of them. That sounds like something from Douglas Adams, I suspect. There are 42 of them, and there's somebody read those books, and they're about 350 miles north of where I'm sitting, up in the Cascade Mountains of California. We have them up there because there aren't many people up there, so there isn't very much radio interference. There's also not very much good cuisine, I got to tell you. But anyhow, that's where the antennas are. 42 of them. It's called the Allen Telescope Array, named after Paul Allen, co-founder of Microsoft, who gave the money to build this first installment, if you will. The idea is to build hundreds of these things, but we don't have the money to do that yet. But in any case, 42 of them. And we use that instrument every day. Right? With radio telescopes, you don't care about clouds or daytime or anything like that. You can use them all the time. So we do. We use them typically 12 hours a day. All right, 12 hours a day. Where do we point them? Well, in the old days, I mean, if you ask somebody, well, Bob, where do you think ET will be hanging out? And nobody knew, but we figured probably on a planet sort of like the Earth around a star sort of like the sun. I mean, they're giving you that answer because there's obviously intelligent life here on Earth. And by the way, I want to dispense with this right away. A lot of times audiences will ask, what do you mean by intelligence? Is there intelligence inside the Beltway? What do you mean by intelligence? And the answer to that is our definition of intelligence is really simple. If you can build a radio transmitter, you're intelligent because then we can find you. Okay? So ask the guy sitting next to you, hey, can you build a radio transmitter? And see what they say, and you can treat them accordingly for as long as you're a member of this club. So the assumption was, okay, their circumstances are going to be sort of like our circumstances because at least we know that works. Sun-like stars have planets that can, foment life and maybe produce something as clever as Homo sapiens. That's not what we're looking at anymore. Not this year. We're looking at a different class of category of targets. We're looking at red dwarf stars. Now, you guys are in an astronomy club, so you probably know all about red dwarfs. Red dwarfs are, there's stars that are smaller than the sun. They're not really all that much smaller. I mean, some of them are maybe 80% the diameter of the sun or 60% the diameter of the sun. Some of them are maybe 10% the diameter of the sun. But if you've taken courses in how stars work, you'll know that making the star a little bit smaller makes it a lot dimmer. Okay, so these stars are the dim bulbs of the universe, and in that sense, they're like some of my relatives. They're dim bulbs. Okay, and it has a couple of consequences. One consequence is that if you want to be on a planet around one of these stars, and there are planets around these stars, by the way, lots have been found recently. The Belgians found one that they call TRAPPIST-1. That's the name of the star, and they found 3 planets going around it, and they're just at the right distance so that the temperatures will be not too hot and not too cold. Might be just okay for life. All right, but those planets have to be very close into the star because the stars are dim. Right? Otherwise, they're too cold. Okay. Well, there's a problem when you have a planet that's really close into a star, because in that case, they tend to get what's called tidally locked. So one side of the planet always faces the star, right? Just like the moon. One side of the moon's always facing the Earth, a fact of which you may be aware. Now, you might say, well, why is that? Why is it the moon, so that its spin is just 1 month, so that it's always looking at us and we don't see the backside unless we get into a rocket? That's not a coincidence, right? When I was a kid, I figured it was a coincidence. It's not a coincidence. Any moon that you put near the Earth there, about the same size, unless it was perfectly spherical, then the irregularities would cause pulls and pushes by the gravitational field of the Earth that would eventually get it locked up so that one side always faced the Earth. There are moons of Jupiter that always face Jupiter. This is a very common phenomenon. So if you had those little red dwarf guys, right, and they have planets very close in, then they're all going to get tidally locked, was the thought, or most of them will be. And that's bad news. Because if you're on one of those planets, then one side is always facing the sun, and the other side's always facing away from the sun. Now, the side that's facing the sun, I mean, that's convenient if you have plants, because the plants don't have to sort of move as the sun moves across the sky. The sun's always in the same place, right? You can bolt all your solar cells into place in one direction. I mean, that's the upside. The downside is one side of that planet is going to be incredibly hot, and the other side is going to be so cold that you're just going to get snow from the atmosphere, and pretty soon the atmosphere is gone. The atmosphere gets piled up on the ground in useless heaps. So people figure, forget it, man. You're never going to get life on a planet around a red dwarf. Well, that just shows you how much astronomers know, because that turns out to be wrong. If you really had a planet around a red dwarf and it had oceans or an atmosphere or something else that you might think is a good thing to have, the winds would be set up between the hot side and the cold side, and they would, carry some of the heat from the hot side to the back side. And if there are oceans, ocean currents would carry some of that heat around too. So, in fact, the backside wouldn't be all that cold, and you wouldn't freeze out the atmosphere. So it could happen. There would be kind of a strip right around the middle of this star. You can imagine this. A strip where everything, the weather, the temperatures are as salubrious as they are in northern New Jersey. Okay. So, and would really simplify the road and rail network too, because everything would just go around the planet. You don't need anything else unless you're going on vacation to the hot side for, I don't know why you'd go there actually, but okay. So having realized this, we are going to look at red dwarfs, because you might say, yeah, all right, well, maybe they can support life, but what's the advantage? Why look at them? Why don't you keep looking at stars like the sun? And I think the advantages are a couple. One is red dwarfs are really dim bulbs, as I said, and that means they don't burn out very quickly, right? They're sipping their gasoline, right? So a star like the sun, you all know the sun is, 4.5, 5 billion years old, and it has about 5 billion more years to go before it goes crazy, swells up, swallows Mercury, Venus, and maybe the Earth, and all your real estate investments become worthless because the oceans have been boiled off the Earth and that sort of thing. I mean, it's not going to be a great deal of fun, but that means the sun lasted for 10 billion years in a state where it was okay for life. But these red dwarf stars, they go for 100 billion years. They're just getting started. Every red dwarf that was ever born since the Big Bang is still out there doing its red dwarf thing. So that means if you look at 1,000 of them or 10,000 or 100,000 of them, on average, they're going to be billions of years older than if you look at stars like the sun, just on average. And this is one case, maybe the only case I can think of, where older might be better. Because if they're older, then they've had more time to cook up something interesting like intelligent life. The other thing is, red dwarfs are very plentiful. 3/4 of all stars are red dwarfs. You don't see them too easily. I mean, with your naked eye, I don't think you can see a single one in the northern hemisphere. In the southern hemisphere, you might be able to see Proxima Centauri, right? I don't know. There are red dwarfs in the south, maybe one or two that you could see without a telescope. You can find some with a telescope in the northern hemisphere, but you need a telescope. I mean, they're that dim. But there's so many of them that most of the close stars are red dwarfs, right? They're just everywhere. Okay, so this might be an advantage because that means if you're looking at a number of them, 1,000, 10,000, 100,000, on average they're going to be only half as far away as if you had looked at sun-like stars. And being closer is also better for SETI because the signals will be stronger. So those are just a couple of reasons why I think red dwarfs are the way to go, and that's what we're doing now. Okay, having said that, maybe I'll say something about Tabby Star. You all know about Tabby Star? They're looking blank. Are you guys blank? Or are you already zoned out? They're probably zoned out. Yeah, they struck me as being zoned out. Really? Yeah, they're not only zoned out, they've moved out. Okay, I'm going to put this to you in a way that even the residents of Metuchen could understand. Here it is. What was I going to talk about? Oh, Tabby Star. Tabby Star. Yeah. This was a big news item about two months ago. Some citizen science project actually was very important in finding Tabby Star, but it was observed by the Kepler Space Telescope. You've all heard about the Kepler Space Telescope. I know many of you are, reducing data for the Kepler Space Telescope. Maybe some of you were involved in the design of the Kepler Space Telescope. Some of you may have space telescopes for pets. The Kepler Space Telescope, in fact, had been looking at this star for a while and found that it occasionally got dim. Well, that's exactly what Kepler looks for. It looks for stars that get dim, but on a regular basis. It gets dim, and then 100 days later, it gets dim again. And then 100 days after that, it gets dim again. It's just a planet going around it, blocking a little bit of light. But in this case, the dimming wasn't occurring on a regular basis. It wasn't periodic. It just got dim, and then it didn't get dim, and then it got dim a little bit less dim sometime else, and then another time, only a couple of days after that, it would get very irregular. Dimming was a lot. It was 22%. I can tell you, that's a lot to dim a star, right? If you look at the sun from far away and Jupiter gets in front of it, you can work it out. It's high school geometry. Jupiter will block about 1% of the light of the sun. 1%, and that's Jupiter. Jupiter's not a small planet. Okay, so what planet could block 22% of the light? And the answer is no planet. So nobody knows what's going on there with Tabby Star. Some people have suggested comet dust, and there's a whole list of things. But one guy at Penn State, which isn't too far from where you are, one guy there, Jason, I'll think of his last name, but it doesn't matter. He said, you know what it is? The guy in the green shorts? No, that's you. Okay. Oh, I thought he did. All right. All right. But in any case, he suggested that maybe they built a giant alien megastructure, right? In other words, sort of like a Dyson swarm or Dyson sphere, something big, right, that occasionally blocks the light from their star. Maybe, a whole fleet of solar panels in space to support their gusto-grabbing, free-living lifestyle by sending all this energy back down to their planet so they don't have to burn coal or oil or any of that stuff. Okay. Well, that would be really interesting if true, but how do you know whether it's true? We used the Allen Telescope Array, and we actually looked at Tabby Star to see if we were getting any signals coming from there. Because that, I would book a flight to Stockholm if that were true, so I could go collect my prize and the check and, have dinner with the king. But we didn't find any signals, unfortunately. Doesn't mean much. It turns out that Tabby Star is very far away. It's 1,500 light years away. So the signal would have to be very, very strong for us to have been able to pick it up. But anyhow, those are the kinds of things that we look at. Mostly the red dwarfs, occasionally other specialized systems. Now, I've already spoken for 20 minutes, so I'm going to go into a slightly different category of thought here. What other kinds of SETI could you do? Well, there's so-called optical SETI. It could be that the aliens aren't using radio signals to get in touch. Maybe they're using light. That would be good news for you guys, because you guys are into light-based astronomy, right? And so there have been experiments for 2 decades now where people will take a modestly sized telescope for a professional, modestly sized telescope might be a 1 meter telescope, right? They're a couple down the road here in Lick Observatory near San Jose, and it's not being used for much because 1 meter is not big enough for a lot of work they're doing there. But you can take this 1 meter telescope, right? Aim it at a star, have some specialized electronics with photomultiplier tubes and so forth, and see a flash of light coming from that star, a very brief flash, like a nanosecond, a billionth of a second, or maybe a millionth. A billionth would be better. Is that ET calling? Could be. Okay. All right. So, that has been done in the past because it makes sense. You might not think it makes sense. Would anybody flash lights at you? And the answer is you could. If you took the biggest laser we have here on Earth, happens to be 30 miles from where I'm sitting over here in Livermore, California. They're using it for nuclear fusion experiments. If you ever come out here, go visit it, the National Ignition Facility. They've got a laser there that's 3 football fields long, all these tubes. Huge, huge thing. It focuses that laser light onto a little tiny pinhead target, for about a billionth of a second. And, of course, heats it up to the temperature of an H-bomb, which is the whole idea. It's to produce nuclear fusion. Okay, that's a different story. But if you took that laser and instead of aiming it at a pinhead, you aim the laser at a mirror no bigger than the table that's in the front of the room there, a mirror that size, and then aim that mirror at a star 100 light years away, and then flash the laser for that billionth of a second, as seen from that star system 100 light years away, it would outshine our sun. Okay, so we can build lasers that can outshine the sun, at least in one direction, for a billionth of a second. Okay. So maybe the aliens are doing this. I mean, they don't know you're here. I just want to tell you that. I doubt that the aliens know we're here. How would they know Homo sapiens is here, right? Well, they could pick up maybe I Love Lucy or some other exquisite TV shows, right? They could pick up a reality television and decide to leave Earth alone. They might be able to, they might do that. But, those signals, we've been sending those signals into space since the Second World War. So they're only 70 light years out. And think about it. If they're more than 35 light years out, they haven't had enough time to pick up I Love Lucy, decide they don't like the jokes, and then send a message back to us, right? Because they can't send the message back any faster than it got to them, the speed of light. All right. So they don't know you're there. Keep that in mind the next time your neighbor says that they're being routinely abducted by aliens. Kind of curious that the aliens are here now. They don't know you're here. But beyond that, they would know that there's life here, right? Because they would have telescopes a little bigger than the ones we have, and they could observe the Earth and see the light coming off the Earth, do a spectroscopic analysis of that light, and of course they would see what's in our atmosphere, right? Water vapor and carbon dioxide and oxygen, right? The oxygen in the atmosphere. In the room you're sitting, 21% of the air in the room you're sitting in is oxygen, or was until you guys got there and breathed a lot of it. But 21%, where did all that oxygen come from? The Earth wasn't born with that oxygen. That oxygen is the result of plants, photosynthesis, right? Mostly microscopic plants, by the way, but never mind. So the aliens might know that there's oxygen in Earth's atmosphere. And, they would draw the obvious conclusion, gosh, Zork, they've got life. It might only be cabbage or grass, but they've got photosynthesis. So they might think, well, maybe they've got more than that. So every now and again, every 2 weeks, it's just a high school science fair project. They flash a laser beam in our direction to see if we respond to that. Now, that could be going on all the time. If I ask you guys use amateur scopes, so this. If I asked you, can you rule out the possibility that once every 2 weeks, there's a spot on the sky that lights up with the brightness of a 4th magnitude star for a billionth of a second? Could you rule that out? And the answer is you could not. You don't know whether that's happening or not. So we're building some equipment that would be able to find such things by looking at all the sky all the time, looking for laser flashes. That's another experiment we're doing. Okay, I'm going to try and wrap up the prattle here so we can get to the questions with a couple of additional thoughts. First thought is, would we tell you, what would happen if we picked up a signal? I get that a lot from the media. And if you go, you walk the streets of, Weehawken, and walk the streets of Weehawken and grab the next 10 people you see. Probably not a good idea, actually. But if you did that and you said to them, hey, suppose they found a signal from space, those SETI guys, you think they would tell us? And I think 8 out of the 10 would say, never. They won't tell us because as soon as they find a signal, the government, the feds will swoop in, right? It'll be like Men in Black. The feds will swoop in and shut it all down. And if you ask them, well, why would they do that? It's because the public couldn't handle the news. Now, I ask you, if you were to open up the papers tomorrow, although very few of you probably do that, but if you were to open up your browser tomorrow and read, scientists find signal coming from 827 light years away, would you say, well, that's it, Mom, they found aliens. I'm not going to school today. I'm just going to riot in the streets. Would a lot of you do that? Probably not. Hey, Jim, is your computer there on, is it walking around the desk? Oh, that's okay. I just took some scopolamine here because, all right. That did not improve their appearance. Keep talking. Oh, okay. All right. So I just wanted to assure you that if we found a signal, you would hear about it essentially right away. It would take us, 3 days, 5 days, a week to verify that the signal wasn't just interference. I got to tell you that. But we've had false alarms, and the Men in Black never showed up. To my dismay, I was really disappointed that not only did the Men in Black never show up, but the White House never called, the Pentagon didn't call. Heck, my mom didn't even call. The one person who did call was one of the science reporters from the New York Times. He did call. He was the only one that was interested. Anyhow, so you will hear about that. So I wanted to dispense with that. If we hear something, you will hear something. That's for sure. Is this better? I think you changed the point of view by 2 inches. Okay. You got to hang it from the ceiling, Jim. It isn't doing much. All right. Secondly, I want to go into another area that is of interest simply because I occasionally consult for movies, right? Anytime there's a movie about aliens, very often I'll get a phone call from somebody down in LA and they'll either fly me down there or they just pick up the phone and talk to me or whatever. And they have almost invariably the same 3 questions, which are relevant to movies, but one of them is relevant to SETI. The first question is, why are they here? Right? I mean, in Independence Day, the aliens come to destroy the Earth. But in Battle LA, they came to destroy Los Angeles. I have to say, from the point of view of somebody living in Northern California, the idea of destroying Los Angeles doesn't actually trouble me terribly much. But whatever. So they always want to know why they're here. There's no reason for them to be here, by the way, I can think of that's terribly, convincing. There's nothing we have here on Earth they don't have there. You know that. Except the rock and roll, and maybe they're studying the biology, or who knows? Maybe they're proselytizing. Maybe they just come here to convert you all to their galactic church. Who knows? But that's the first question. The second question is, what weapons will they have? And that's also kind of a bizarre question. I mean, if they can come here, how much more advanced are they? Thousands of years, who knows? But if they can come here, they're much more technically advanced than we are. So to speculate on what weapons they're going to have would be like asking Julius Caesar, what weapons do you think the U.S. military will have in 2016? And Julius Caesar would be thinking in terms of spears and stuff like that. But that is actually not what we have. So that question doesn't make any sense. But the third question they always ask is, what will they look like? What will they look like? I don't know what they'll look like. Does anybody know what they'll look like? Just go to the zoo and look around. They don't look like you. But I'm sure everything in the zoo has at least 90% of its DNA that's identical to yours, right? And they still don't look like you. I mean, unless you look like a fish or a snake or something like that. So I don't know what they look like. But that's actually an interesting question, I think, for SETI. Not because we care what they look like. I mean, you may care, but you're not going to find out until we pick up a signal and they send a picture. Hey, look, Bob. It's a little gray guy with big eyeballs and no hair, no clothes, no sense of humor. All right, that's what they look like in the movies, of course. But what I want to point out is this other thing, and that is, we've had radio for about 100 years. I mean, Marconi was doing stuff in 1900, so it's a little over a century we've had radio, and we're already that's the minimum level of ET. If they're not at that level, we don't hear them. Right? I mean, if the ET are Neanderthals, Well, that's fine, but you're not going to hear from them. Okay. So they have to at least be at our level, really, for us to even have a chance of picking up anything from them. But we're in the process this century of inventing our successors, right? We're building thinking machines. Now, you can spend a lot of money on a computer and it can, a chess computer, and that computer can beat anybody in the world in chess. You can build a computer that can beat anybody in the world in Go, and apparently can beat most people at Jeopardy too. But you spend a lot of money for a machine that can do one thing really well. Okay. What you really want is generalized artificial intelligence, where you spend a lot of money and you get a machine that can do everything you can do cognitively as well. In other words, take your job, right? If you have a desk job. If your job is not a desk job, maybe it doesn't take your job, but okay. All right. So we're doing that in the 21st century. The point is, once you get a thinking machine, the first thing you ask it to do is design something smarter than it is. You build that. Then you ask that machine to design something smarter than it is. And within 20 years, you have a machine that's smarter than all people put together. After that, I don't know what the machines do, but it's been widely speculated that some of them, at least, will get up and leave, right? You might say, why would they leave? This is New Jersey. Well, it's not that they're moving to Oklahoma or anything like that. It's just that as attractive as Metuchen, Rahway, Lyndon, Elizabeth, Newark, as attractive as all that is, the facts are what they need is a better source of energy, maybe some raw material to build spare parts. They're going to get out of here, right? Some of them, maybe most of them don't, but if some of them do, and there's no restriction on their intelligence, unlike us, right? I know you all think you're smart, but that's because your parents have been telling you that ever since you were a kid. The facts are, babies born today are no smarter than babies that were born during the time of the Roman Empire. I mean, you might have a different education system. I won't go there. But, I mean, it's the same stuff, right? Whereas the machines, it's not the same stuff. They double in capability every 18 months now. That's what we do. But what will the machines do? So I think the bottom line of this simple argument is that any society that's out there that's more advanced than we are, so that they have a strong transmitter that we could pick up, is likely to be beyond biology. They've moved on to thinking machines. And this is something that the movies, of course, always get wrong. I think if we pick up a signal, it's very likely not to be coming from, protoplasm, from biology. It's much more likely to be coming from a machine. I don't know how that strikes you. I don't know how it strikes you, the idea that, maybe we're inventing our own successors in this century. A lot of people don't believe that, by the way. And I was up at Stanford, which actually isn't very far from here, a couple of years ago for some TV show. And the head of the Stanford Artificial Intelligence Research Group was sitting there. And I went up to him and I said, so are we going to have a machine that can write the great American novel by 2050? And he just looked up at me and said, yes. That was it. That's all he said. Okay. So maybe he's building it. Maybe he's, well, whatever. All right. Having said all that, I will end by repeating something I said at a talk I gave a couple of years ago, actually now, in Germany, in which I bet everybody in the audience a cup of Starbucks that we'll find ET within 24 years. The reason I say that is because SETI technology keeps getting better. It too follows what's called Moore's law. It doubles in capability roughly every 2 years. So if you translate that into terms of how many star systems can you look at every year, that keeps going up. And within 24 years, we should be able to have looked at 1 million or more star systems. And just in my gut, I had the feeling that if you can look at 1 million or more, you're going to pick something up. That could be wrong. That's why I only bet people a cup of Starbucks. I don't bet them anything more substantial than that, but I will bet them that. My wife, by the way, is buying Starbucks stock. Okay, so that's why I say there are a lot of young people, at least in the front row. And here's the deal with them. By the time they reach middle age, either they can read this story about how we finally picked up a signal showing we're not the only kids on the block, or they get a cup of coffee. So it's a no-lose situation for them. All right, I got to stop talking for a while, let you guys ask some questions, because I know how stultifying this can be. Okay. But you can still hear me, right? All right. Now I'm going to speak Lithuanian for the next 2 minutes, just because I can't see them. Um, yeah, I think what is it? 250 meters, the FAST telescope. It's it's. I'm sorry. It's more than that. 500 meters. That's what I meant to say. 500 meters. It's it's not quite twice the diameter of the telescope in Arecibo in Puerto Rico. I don't know if any of you have ever been to the Arecibo telescope there. I would recommend that you go down there, actually. It's not very far to go to Puerto Rico. And then once you're in San Juan, it's like an hour and a half drive up to the observatory. And they have a visitor center, and it's actually very impressive. And it's also under threat. The National Science Foundation has funded that operation for a long time, but they have limited funds, and they may say, look, uh, we want to fund something else. So, you ought to see it before something terrible happens to it. I don't know that something terrible is going to happen to it, but there is that chance. It's for real. Anyhow, so this new FAST telescope in China is bigger, but it's bigger by, I think the diameter is, almost twice the diameter of Arecibo. So how does that change SETI or astronomy or anything else? Well, obviously, bigger is better. I mean, you know that. You guys have an 18 and a 26 inch? All right, so that's more or less the relationship between Arecibo and the FAST telescope in China. Is the 26 inch so much better than the 18 inch that you never use the 18 inch? No, no, right. Can it see things that the 18 inch can't see? Yeah, there are some things. There are some things. So I think it'll be the same thing. It'll be of interest for radio astronomy simply because it's more sensitive. Okay, but again, the sensitivity goes up as, of course, the collecting area, the square of the diameter, if you will. So it's maybe 3 times more sensitive. But those of you who are still tuned in will recognize that that means it can only see things the square root of 3 farther away than Arecibo, and that's 1.7 times or something. It's the ratio of the diameters. So that opens up maybe, well, cube that, so 3, it's 5, 6, 7 times. I'm doing this arithmetic in my head and probably incorrectly, but there are 5 or 6 times as much of the universe is accessible to this as would be accessible to Arecibo. Is that going to change the world of astronomy? My bet is that it probably won't, but I could be wrong. And will it be used for SETI? I think so. The Chinese have certainly shown an interest in that. In fact, they're not the only Asian country to be interested. The Japanese have been interested for a long time, and there are some other countries that are actually interested in doing SETI too. But being interested is one thing, and actually doing it is something else, and we'll see. I think a more interesting instrument for the future of SETI might be the square kilometer array that's being built in South Africa and in Australia, because that really is much bigger, much, much bigger. And you can always say, it's just going to do astronomy, but we'll have one feed that goes off to specialized receivers looking for narrowband signals, which are the type that SETI looks for. Long answer to a simple question. It's much better. I can see them all. Most of them, they're all hominids. You didn't tell me that. Okay. Yeah, it's still viable. It's still out there. It's called SETI at Home, right? That's it. It's a desktop thing. It's just a screensaver, and it notices that when you haven't punched any buttons on your computer, when you walk away from your computer to make yourself a tuna fish sandwich, in case you've always wanted to be a tuna fish sandwich, then it notices that you're not there, and it switches over into this mode where it downloads some SETI data, and then you process it with your CPU as long as you're not using your computer. That idea is, I mean, they've been doing that for about a decade, and they've had on the order of roughly 10 million downloads of the screensaver. They don't process all their data that way. There's a certain fraction, but it's been enormously successful. It's not our project. This is a project of the University of California at Berkeley. They too have a SETI program, and they use it not only for, well, they use it for the data that they collect at Arecibo, but also for data that they're going to collect as part of something called Breakthrough Listen. This is a big initiative that was financed by a Russian billionaire, actually, who lives pretty close to here. It's a good use of your computer, is all I'm saying. You and 10 million others. Would it not be carbon based? Well, ask yourself, why are you carbon based? I mean, did you just decide to do that when you were 3? Hey, you're carbon based. You're carbon based not because if you step outside and dig in the dirt there, that there's all that much carbon in the dirt. I mean, there's carbon in the dirt, but there's a lot more silicon in the dirt than there is carbon, and you're not silicon based, right? The reason you're carbon based is because, to begin with, carbon. When you're in 11th grade, you take chemistry, and you learn that carbon has 4 covalent bonds. It's a friendly atom. It likes to hook up with other atoms to make big complex molecules, right? All of northern New Jersey is covered with these giant metal tanks that are holding hydrocarbons, right? Right, like the chemical coast of New Jersey. Okay, that's because carbon likes to make complex molecules, and that's what you are. I mean, you probably don't get up in the morning and say, "Well, Mom, another day of complex chemistry," but that's what life is. So whatever else you're worried about, you can at least think of that, right? Now you could say, "Well, yeah, but silicon is underneath carbon in the periodic table, so silicon has 4 covalent bonds too." It does, but the atom is a little bigger, so it doesn't work so well. I'll give you an example. You take carbon and you have it hook up with oxygen, as I say, it likes to hook up with anything. Hook up with oxygen, you take 2 oxygen atoms and a carbon atom, and you get what? CO2, right? I mean, you all are making lots of CO2 with your SUVs or whatever. But CO2 is actually a biologically very interesting gas because plants like it, okay? Now you take silicon and you hook it up with 2 oxygen atoms, and what do you get? You get SiO2, silicon dioxide. Silicon dioxide is better known as quartz or sand, right? And plants can't do much with quartz, right? Nor can you, by the way. So, I mean, you can go to Atlantic City and eat the sand, but it's not nutritious. It doesn't taste good either. So there's a real advantage to carbon. Carbon can do this, and there aren't any other atoms that are nearly as good. So, bottom line, if we find life in space, I mean, who knows? But I'll bet you something that it's going to be carbon based. If it's biology, it'll be carbon based. You mean in terms of, do we know the terms in the equation? Yeah. Right. By the way, can everybody hear the questions there? Yeah. Okay. I haven't been repeating the questions because I figured you're all in the room together. Maybe you can all hear them. Yeah, the Drake equation. Frank Drake was here yesterday, actually. Frank doesn't come in as often as he used to. He's now, what, 83 or 84. Uh, but he looks the same as he did when he was 21, I got to tell you. It's amazing. I mean, it's just amazing. It's good news and bad news for Frank. At 83, he looks like he's 21. But then again, at 21, he looked like he was 83. I don't know. Right. But Frank wrote that equation in 1961, the Drake equation, to try and estimate how many societies are out there broadcasting signals that are going through your bodies as you sit through this. Okay. And the gentleman's question is, do we know some of the 7 parameters in that equation any better today than we did back in 1961? And the easy answer to that is no. In fact, well, we do know some things. The one thing we know much better is what fraction of stars have planets and what fraction of those planets are sort of like the Earth. Those 2 terms we know better. But I got to say, back in 1961, they guessed at what those values might be. And it turns out that the guesses were pretty much the same as what we've learned, 50 years later with experiment. So it isn't that we can better come to a conclusion about the Drake equation. The trouble is, you can learn the values of 6 of the 7 parameters in the Drake equation, but if you don't know one, then you don't know the answer. It doesn't help to learn one more very much. Yeah. Well, they could be. I mean, if you don't have the technology to pick it up, you don't know, right? That's one of those questions where you can say it's possible. Maybe they're, sending subspace communications or whatever they use on Star Trek, that they're communicating with physics we still don't know. Possible. But the usual analogy I use here is it would be like if you went back to 1492 and you went up to Chris Columbus and you say, Chris, there's a better technology for getting across this ocean than that stupid wooden ship. Just sit around for a while until we invent jet aircraft, and then you can cross the Atlantic in 6 hours eating bad food off your lap. You could tell them that, but it turns out that the wooden ships were good enough. So we're kind of in the same situation. It may be that you're right, and that 100 years from now we'll realize that radio waves and light, all that that was all the wrong approach. But you know it might be the right approach. So I think it's better to do the experiment. But that's just me, and after all, it's my job. Right. Yeah. Is it going to be deliberate, a deliberate transmission, or what we call leakage? Right. In the same sense that WNYC, that's leakage. They're not deliberately trying to reach the aliens. Okay. We don't care, obviously. Who cares? Right. Either way, it's a win. Right. But it is true that if they deliberately beam something to Earth, then that's going to be probably much easier to find because they'll put all the power aimed our way. Right. Okay. I mean, the problem with, for example, FM radio, right, or television. Those are both high frequency transmissions that go into space, go right through the ionosphere, right? The television stations on top of the Empire State Building, that antenna, that those signals go out across New York State, Connecticut, New Jersey, Long Island, whatever, and then they sail over the last rooftop Yagi and they go into space. Say. They just keep going. Okay. But because they're aimed at the whole horizon, because they want as many viewers as possible, the signal strength in any given direction is very, very low. So if the aliens deliberately send something our way, they'll focus it toward us and it'll be easier to find. On the other hand, look, I said it's only been 100 years since Marconi, and you're asking me to speculate on what the aliens might do internally for themselves. They might have very powerful radars, right, just to look for long period comets, because as you know, long period comets, you don't know about most of them, right? And they could come, to the inner solar system and ruin your whole day by obliterating the Earth. So it's important to have that kind of technology. So maybe the aliens have that. Maybe they have other uses for radio. If you went back to Marconi's day and said, "Hey, Marconi, what do you think your invention is going to be used for in 2016?" He'd have a bunch of ideas, but I bet they'd all be wrong. So I don't know. The advantage, by the way, of the leakage is they don't know we're here. So maybe the leakage is a better bet. How smart do I think they are? I would say very. How's that? No, look. Well, yeah, they could be a lot smart. Look, about 2 million years ago, even 1 million years ago, come to think of it, 1 million years ago, there weren't any Homo sapiens walking around, but there were our predecessors. They were forest apes, and their brains weighed 2 pounds. Your brain, once you grow up, anyhow, your brain will weigh 3 pounds. Well, the difference between 2 pounds and 3 pounds is that at 3 pounds, you get to live in New Jersey. At 2 pounds, you get to live at the Bronx Zoo. Okay. So there's a big difference. And you can imagine if the aliens had 10-pound brains, wow, think of what they could do. But as I said earlier, I suspect that most of the intelligence out there isn't actually soft and squishy biological intelligence anyhow. Most of it's probably machine intelligence. And then the brain can be as big as, it can be as big as Pennsylvania. I mean, it can just be arbitrarily large. Well, what Yeah, what Steve was talking about was what's called active SETI, where because we do passive SETI, we're just listening. We don't have any transmitters on those 42 antennas. I mean, we couldn't send anything out into space, right? We just listen. We just listen. And there's no danger in listening, right? You tune in Rush Limbaugh on the car radio, and I know that many of you probably do that. You tune in Rush, right? But there's no danger. It isn't that Rush, hey, that guy tuned me in, and he's going to jump into your car and start giving you a hard time. Not going to happen because he doesn't know, right? So if we tune in the aliens with our SETI equipment, then there's no danger in that. But there are people who would say, yeah, but if we do tune them in, let's send them back a message. Hi, we're the Earthlings. You know, we got a lot of used cars. You interested? Whatever you'd say. And Hawking was considering that because there are people, in fact, there was a guy here at the SETI Institute who wanted to deliberately broadcast. In fact, to use the antenna in Arecibo in Puerto Rico, because it does have a transmitter, a very powerful one. It's used for mapping asteroids. It was used for mapping Venus. It's like a megawatt or two megawatt transmitter on a very big antenna. That makes a very, very strong signal, probably the strongest signal that you can make on Earth. Okay. And he was going to use that and just ping some nearby stars that are only maybe 10 light years away, with the thought being that, you know, he'll still be alive if they respond. Okay. And so Hawking was kind of addressing that. He's saying, hey, look, maybe it's not a good idea to let them know that we're here, because they may get cheesed off at the idea, not like the competition or whatever, and then send their interstellar battle wagons and destroy Earth, as you will see in Independence Day. Right. Okay. Well, I don't worry too much about this. And it's not because, I know anything about alien behavior. I mean, it doesn't seem terribly reasonable to me that it would do this. That would be very, very expensive, right? That would be an incredibly expensive thing to do. And it's not clear what benefit they'd get out of wiping out everything here on Earth. But here's a different argument. I mean, because maybe you don't agree with me. Oh, no, they're going to wipe us out only because you feel that, somehow we deserve it. I don't know. But here's another argument, and it's this. We're already broadcasting into space that we're here, right? And not SETI people, but the Liberty Airport, for example, here in Newark, right? They have powerful radars, and they're broadcasting to space 24/7. Right? And you could say, okay, well, that's a dangerous thing, but they may not be able to pick that up. It's too weak. Well, they don't have to have a very, very big antenna to be able to pick that stuff up. Yeah, bigger than any we have, but not that much bigger, actually. So if they're only a couple of 100 years more advanced than we are, they've got the equipment to pick up that stuff. And if they're not a couple of 100 years more advanced than us, they can't send rockets here and destroy us anyhow. So the bottom line is, any society that could be a danger to you, right, has the technology to find that we're here. And you can say, well, then we better shut off all these radars. And I ask you, do you want to land in Newark at night without those radars or not? I say you don't want to do that. He agrees. Well, I don't know what the implications are. I mean, I would ask you, what are the implications on the multidimensionality of time and space on you? I mean, it may have some implications in terms of the physics, because in the end, your biology is just chemistry, and chemistry is just physics. So in the end, it's all physics, unless you're a mathematician, in which case it's all math. But to the extent that it's all physics, and to the extent that ideas like string theory may govern physics, then that's germane. But keep in mind that one of the big triumphs of astronomy of the last 500 years has been to show that the physics is the same everywhere in the universe, as far as we can tell. So they've got the same physics we do. So, I'm not sure that there are any implications I can think of. Yeah, well, it could be. You go to Mars. There are people who want to go to Mars. There are a whole bunch of people who've signed up to go to Mars, and often with a one-way ticket. I talked to some young woman who was doing that. I said, "What do your parents think of that?" She said, "They're down with it." I don't know. They never liked their daughter. I don't know what it is, but and it could be. There's probably no life on the surface of Mars. Terrible place. All this ultraviolet light, completely dry and cold, by the way. But if you go down, 100 feet, it might be just great if you're a microbe. Okay, so there might be a lot of microbes on Mars. I mean, it could be. We don't know. but there could be. There could be. And so if we go there, and of course, you drill a well because you need to get some of that water, to drink, and you bring up some of the microbes, and then they kill you all. It could happen. But the fact that microbes on Earth could kill you is because those microbes have co-evolved with you. There's been 4 billion years of history with you and everything else, right? Because life got started on Earth 4 billion years ago, and it all has to deal with the other life on Earth. So it's very well attuned to you. If you look at what bacteria do to you, they latch onto a particular kind of cell, and they're all set to go when it comes to you, but they're not all set to go when it would come to a Klingon, for example, that had a different biochemistry, right? The details would be different. So I don't think that there's much danger in that. I mean, it's a counterexample, and this is often offered by a guy by the name of Bob Zubrin, who's very keen on us going to Mars. He said, because people will point out this danger, he say, we've had rocks landing here on Earth from Mars for 4.5 billion years, which is true, right? They're Martian meteorites. And some of those rocks might have had Martian microbes in them. That's even been claimed occasionally. And they could have survived the trip if they're inside the rock, but they didn't wipe out all the life on Earth. They didn't do anything, right? So I think this, if you want to worry about that dental appointment next week, I mean, that's justified, but I wouldn't worry about the microbes making you sick. Okay. Yeah. How do you know life when you see it? I mean, that's a real, if I understand you correctly. That, that's a real question. I mean, that was the question that they faced back in the 1970s, right? When we sent the the Viking landers, 2 of them, to Mars to look for life, right? Because they had to design experiments to look for life. Now, it's pretty easy to design an experiment to look for a Martian who just stands up there and waves at you, right? That's pretty easy to recognize. But what if it's just a microbe, and it's a microbe that it doesn't have DNA, it has some other molecules, and how would you know that it's even alive? Or worse yet, that it once was alive a couple of billion years ago. So all they could do was design experiments that would look for the kind of life we know about here on Earth. That it has metabolism and it takes in certain gases and exhausts other gases. They tried to make it as general as they could, carbon-based, those sorts of things. It's actually a very difficult question. We can't even define life very well, right? I mean, if you take 10th grade biology, you open up the biology book and the first page is, what is life? Right? And they say, well, life has metabolism and reproduction and it has this and that and all that stuff. But that still doesn't define life because you can think of counterexamples, right? Mules are alive, but they don't reproduce, right? Fire reproduces, but it's not alive, and they all have metabolism and so forth and so on. We don't actually have a good definition of life. Believe it or not, we don't have a good definition of life. This is a problem in astrobiology. So the answer to your question is, we don't know the answer to your question. It's actually hard. There are some sophisticated suggestions, like looking for what's called homochirality, which is the orientation of the molecules. That's very special here for life on Earth. Sort of these sophisticated ideas. But in the end, probably the best thing you can do is just to take a sample of what you think might be life, put it under a microscope and see if anything's wiggling around. Well, we're not spending a lot of money on. Are you talking about humans on board, or are you just talking about spacecraft? Oh, yeah, yeah. Well, I think that's an ultimate threat that we will have to confront. But I mean, the sun is getting brighter every day. I think you're probably aware of that. That's just natural stellar evolution, and eventually that's going to be a problem, but not for about at least 100 million years, and probably many hundreds of millions of years. So this question is really in the deep, 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 deep future, and to even assume that our species is going to be around 100 million years from now is being very optimistic. I mean, this was like asking the dinos 100 million years ago. So, what are you guys planning to do in 2016? Have you booked your cruise yet? You know, they didn't foresee that there was a kind of irrelevant question. So, I don't worry about that. But if you're talking about, the foreseeable future, right? This generation, the next generation, maybe the generation after that, there are no plans to send humans into deep space. We can't do that. You can't do it with chemical rockets, frankly. You just can't. There's not enough energy in chemical rockets to send somebody with everything you need to stay alive to the stars and get them there fast. Our fastest rocket, right, like the one that, took the New Horizons spacecraft to Pluto, right? That was going like 10 miles a second or something like that. 10 miles a second is great, right? If you're going to, I don't know, Cape May, but it's not great if you're going to Alpha Centauri because at 10 miles a second, it will take you 75,000 years to get to Alpha Centauri, which is too long. I mean, even if you got a lot of peanuts on board, that's too long. So, we're not doing that. We're just not doing that. And we're not doing that, 10 years from now either. So the question really is, well, should we send people even to Mars? Some people question that. I think we do want to go to Mars. Do you want to go to one of the moons of Jupiter? It's a very tough environment, and it'll take you a long time to get there. And if you want a round-trip ticket, it's even tougher. And maybe everything you need to know about Jupiter, or more interestingly, its moons, you can learn with robots. The bottom line here is always the argument, should we be spending all this money on human space flight, whereas robotic space flight is so much cheaper, does more science, and doesn't kill anybody? Okay? And so a lot of people will say, oh, forget sending humans into space, let's just send the robots. But I tell you, you go into a sixth grade classroom and ask the kids, how many of you would like to go to Mars? And all the hands will go up. And now ask them, how many of you would like to be an engineer designing rovers that go explore Mars? And some of the hands will go up. So there's something about sending people into space that has a cachet and appeal that robots don't have. Okay, wow. Well, what the wow signal? It's famous. This is the triumph of marketing over product. Uh, the wow signal was found at Ohio State University in 1977, I believe, using their big radio telescope there. They called it the Big Ear, which was, I thought, a pretty good name, much better than most radio telescopes. The Big Ear. It's now a golf course, by the way. But in any case, one night in 1977, it recorded this signal that looked like just what they were looking for, right? Keep in mind that back in those days, the way you did SETI was you just recorded all the data and then you looked at it later, right? You couldn't do anything more than that. And they found dozens of signals in those days. Today, where you can check it out right away, if you find a signal, you can immediately see, is this just, a satellite going overhead, or is it the radar down at the airport, or what? Or is it ET? You can make that decision real time now. You don't get these false alarms. Back then you did. So that suggests they probably all were, just interference from Earth. But nobody knows what the wow signal was. It was automatically reobserved 70 seconds later, so a little over a minute later, and it was not seen again. We are using, I think even this week, we are using the Allen Telescope Array to look again in the direction of the wow signal. We'll do a fairly serious search. That's because there's a guy in Chicago by the name of Bob Gray, who's been very interested in the wow signal forever, and so he wants to keep looking. And we will do that. I don't know that we'll find anything. I doubt we will, but on the other hand, we still don't know what it was. But maybe we'll never know. To claim that it was ET wouldn't be good science, though. Hope so. My, my favorite state.